All right, that should be live now. Sorry about that. Okay, so anyone that's new, um, we use the chat window pretty much throughout all of this. It's expected that you contribute. You don't have to know all the answers, but like a conversation, just say yes, no, I don't get you, I do get you. Just some response. It makes it a lot easier for me to communicate. So first things first, if you are here, just say hi, and if you can hear me, tell me you can hear me. So it's always something I need to check at the start. So I'll just wait to make sure everyone can hear me. That. Can we hear me? Or maybe not. Maybe I'm lagging a bit. So just type in the chat if you can hear me. I just want to make sure before I start. Okay, cool. All right, so what I was thinking to do is start off with some revision. If anyone's got some good questions, we can also start with that. I'd first start with revision. If there's questions about the assignment, I'll wait till a little bit later, just because most people join like 10 to 15 minutes late, generally. So I might start with revision. And what I was thinking is start from week 2 and go over a bunch of stuff, just for 2 reasons. Firstly, for exam revision, but secondly, because it may give you hints to the assignment. Okay? Are we happy with that? All right, so the first lecture kind of introduces you to a bunch of different terminology, and this is quite important. So what I'm going to do is just do a little bit of code, and we'll just make sure that we can use proper terminology in the exam if we have to talk about anything. So I'm just going to write this code. I'm going to put hash include standard IO-H, put hash define pi 3.14, then I put in main, and then I'm going to set up a bunch of variables. So I'm going to have float A, I'm going to have float B becomes 4.2, and then I'm going to have A becomes 3. Okay. I'm also going to have, let's say, printf %d A. So this is a fairly simple code right now. We all should be aware of what this is, and we're just going to talk about what each thing is and what it is called. And this is quite important. So we also need plus the. So I've got some very simple amount of code here. Okay. Now, with this, we should know what each of these constructs are. before we get into the exam. And this should take us a couple of seconds. So just in the chat, something about that. What else do I want to do? What's that called? What's this called? Oh. Okay. E. So can we quickly go over what each one of these is? So the first one, A, is a comment. You can either use inline comments or you can use multi-line comments. Okay, I hope we're all right with that. The hash is called a directive. I can spell. And they are handled by the preprocessor. Okay, and we'll see this would help. I wrote that right, or precompiler. Either one's fine. And we'll see this a bit later in the later lectures. But we know that the include allows us to include other libraries, and the define allows us to define macros. Okay. We also have a bunch of other directives like ifdef and so on. C, we have the function header. Okay. So this is called the function header. We have the function body. Okay. And the actual function is called the function definition. Okay. So that's something to be aware of. Now, one that's fairly simple at this stage. I'm not too worried about the function body and function header. What I am concerned about, and this goes back many weeks. So if I gave you a question about these two, how would you describe A and how would you describe B here? The line. I'll call it 1 and 2 actually. I use the verbs. So how would I describe 1 and what it does, and 2 and what it does? So put in your comments what 1 does and what 2 does. And this is important because there is a big difference in terminology. So just put in comments if you don't know, just say you don't know. Okay. Yeah, so we got a good answer already. This here is called declaration. And this is called initialization. Initialization is both declaration and assignment in the same step. Okay. So when we do both, we just call it, we initialize B to 4.2. Okay. The decimal point, it's a floating point number. So we can store floating point numbers. So it's just 4.2, the number 4.2. Does that make sense? This is a decimal point in this case. We will see that dot operator later instructs, but for a number, that is the number 4.2. Does that make sense? Or have I misinterpreted the question? Yep, cool. All right. So we've got a whole heap of other statements here. Now, we have to remember, so what's circled here is called an operator. And here it's the addition operator. However, we have to remember, and this goes back to the point that was just raised, in C we have overloaded operators. So for example, the decimal point is a good example. This can be used as a decimal point, or it could be used to access members of structs. Okay, and we've seen this a lot with pointers as well. Okay, so an operator has a different meaning depending on where you put it. So if you have to write something in your exam, do not say ampersand. You say address of. Okay, because if you're talking about the address of a variable, you're not talking about the ampersand of it, because this may have different meanings depending on how it's used. This could mean bitwise and. Okay, so we do have to be careful with our operators. All right. Okay. What is this called? Not the actual function, but what it's doing. So if you're here, please use the chat. It makes it a lot easier for me to go through this, and it'll make it a lot easier for you to get concentrated. I don't know how much of a delay there is either. There's not much of a delay. So what's number 3 called? What are we doing with the function? And as I said, if you don't know, just please say don't know. So this is called a call, a function call. Okay, so when we actually use a function, not define a function, so this is the definition of main, but we actually want to call a function from within another function. And so this is called a function call. Okay, this could be any kind of function, it could be scanf, it could be your own function, and so on. Okay, so just terminology there. Okay. Now the other big one is this equals operator. So don't forget that it's assignment. Okay. All right. It is not equals, it is assignment. All right. So that's a basic program there. Now, we do need to be aware of a couple of standard types. Oops. So we have car and we have short. We have float, we have double, we have int. So which one of these is of integer type? So which ones are integer type? If you're here watching, please use the chat. It'll just make this quicker. If you don't know, don't say you don't. Okay. So this is something that we went on very early. So the integer type ones here is A, B, and E. These are all integer type. Okay. And this is something you need to be careful of. Okay. Unfortunately, it confuses a lot of students because this one is called int. And the reason it's called int is because it's the standard size for an integer. But a car is an integer type, a short is an integer type, and int is an integer type. Okay. The type itself, all these integer types have a different storage size, but they're all integer types. Okay. They all just store a whole number. So if I have car A equals 1, that becomes 1. Short B is 1, and int C is 1. If we have a look in memory, you definitely need to know how many bytes a car is before you go into the exam as well. So how many bytes is a car? Yeah, beautiful. So 1 byte. Okay, that you definitely need to know. Okay, so we're going to treat this as a 4-byte int. So ints change depending on the system. Short's always 2, car's always 1. Okay, the car, you need to know that it's 1 byte because that's really fundamentally important. Okay, so in memory, and we're going to treat this like it's big endian. Okay, that doesn't make sense. We'll get to that later. But A, B, and C, the value 1. Now, in memory, it's all stored in binary. So A holds 1. B holds 1. I should have done 2 to make it a little bit more clearer. But oh well. Okay, so we've got our variables A, B, and C, and you can see they all can hold the same number. They can all hold 1. Now, they can all hold, if they're signed, from 128 to 127. So all of them can hold this, okay, if they're signed. But once we go over that limit, car can't hold that. Okay, so short and int will still be able to hold negative 108 to 32,768. Okay, that's not right. Actually 7. Okay, so shorts can hold this, and you can see that that is a subset of that, and you can see that it has more memory. Okay, and then an int can hold, well, a 4-byte int can hold 2 billion, sorry, 483,648. to the same thing, minus 1, 3, 6, 4, 7. Okay, so you can see as we increase the bits, we can store a lot larger. But you see that they still hold the same information. Okay? Now it is important that you understand how memory is stored for integer types. We're not going to concern ourselves too much with how floating points are stored in memory, but it is still important. Okay, so these are all integer types. Does that make sense? No, you're not. No, you're not expected to memorize the range. But you should. This is why I'm pointing these things out. You should know how big a car is, and you should know that all of these are integer types. Okay, so I'm pointing out important things. Does that make sense? Say yes if it makes sense, say no if it doesn't make sense so far. I know there's quite a few people watching, but not many people comment. Cool. So this was something very early on. And if you have a look at your reference sheet, you'll notice that it tells you these are integer types. This alone is not an integer type. It actually isn't integer, it's int. That is its type. Car is its type, short is its type. The name of the storage type is just giving you an indication of what's suitable to store in it. Okay? So cars can hold numbers between -128 and 127, or if it's unsigned 0 to 255. But cars are suitable for storing ASCII characters, because if we have a look at the ASCII table, it goes from 0 to 127. So it's suitable for storing ASCII characters. But if we have a small number that we know is never going to be below 127, we can use a car. That's perfectly fine. Okay. Now, which ones are floating point type? C and D, beautiful. Okay, so don't get confused by the word float. And you'll always refer to it as float. Okay, and you'll refer to this as double. You don't refer to it as a floating point type because you don't know which one it is, and there might be more. Usually you refer to this as single point precision, you call this double point precision. And floating points can store floating numbers. Okay? Now, it doesn't have to do anything with decimal as well, and that's something to remember. We could have a floating point binary number or a floating point hexadecimal number. We don't cover this in the subject, but remember, even a float and a double is stored in memory as a binary number. Okay? We're not going to look too much about that in memory. If you're interested and keen, you can look it up. There's some really good diagrams of it on Wikipedia, but we're not going to ask anything related to that because floating point numbers are actually quite complex when it comes to storage. Okay? So this is important. So my next question is, can I
So I mean, I won't give you that. I'm just going to grab up something. So leave you a the character A. Okay. Now you'll notice that I put the single quotes referring to the character, not a string. So this is a single 8-bit character or 1-byte character. In binary, this A is 0, 1, 0, 0, 0, 0, 0, 1. Okay? So that's the value in binary. Now, I'm going to write 3 lines of code here. So I'm going to write car A becomes A, short B is A, and int C is A. And then I'm going to go printf. I probably should have given you the decimal value as well. So that's 65. Okay, so 65 in base 10, and at 0, 1, 0, 0, 0, 0, 0, 1 base 2 or binary. So I'm going to go %d, %d, %d. And I'm going to go A, B, C. Will this compile? Is my question to you. Why or why not? Obviously assume that there's all the standard library and stuff and all that jazz. Will this compile? Sorry, it's a little messy, but I'm looking at this at the moment. Actually, and if you don't know, just say, I don't know. Please, it's easier for me. Ta-da. Oh. Yes. Yes, will compile. It's perfectly legal. It's perfectly fine. Okay? However, as we said, a car is suitable for storing a character, an ASCII character. But no, these are fine. These are perfectly fine. Okay? So these will be implicitly converted into ints, but because they're all integer types, it'll print it. It may give you a warning, but actually unlikely. Depending on what warnings you have set, it probably won't actually give you a warning. But a message with warnings as well. So warnings will change quite significantly depending on the compiler you're using and the settings. Now we have warnings all on, so we usually see all the warnings. But you can set different flags to see different warnings, and different systems will handle things slightly different. So if you're compiling your code somewhere else, you may not get certain warnings, or you may get more warnings. So in Big Endian, okay, A will store 0, 1, 0, 0, 0, 0, 0, 1. B will store 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, and blah, 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 lots of zeros, 0, 1, 0, 0, 0, 0, 0, 1. So why? So this will print out 65, 65, 65, okay? here. But we can see that car is the suitable one for storing it because we can see that ASCII characters only are in the first byte. And so if I use a short, I'm just wasting a byte. If I use a 4-byte int, I'm wasting 3 bytes. Okay? But there's nothing stopping us using it. All right? Does that make sense? Okay? This, see, what I'd love to do is love to rename these variables to like byte, 2 bytes, 4 bytes, or something like that, so that this name car does not confuse people. It's something that does confuse people. The name car doesn't mean that it holds a character. It's just suitable for holding a character. Okay. And these names are quite old. Okay. So they didn't really think about the naming very, very well. Okay. So this is why it's suitable. And this is why we use car for strings and for holding characters, because we're just wasting space otherwise. However, that's not the same in other languages if we're using Unicode. Okay, so in Java, you actually need a 2-byte car, which is kind of interesting, but that's a story for another day. All right, we all happy? We're all up to place? Okay. Okay. The big question of the day. What does this F stand for? And I know this. We'll get to signed and unsigned. No, you don't need to know how much memory, but you do need to understand a couple of key points about unsigned. Right. Can everyone that's watching, I know there's quite a number of people watching, please use the chat. Just as some validation that you're understanding what I'm saying. And if you're behind, just come to the time we're at. Okay. If you don't know, just say don't know. Okay, so it is formatted. Okay. Now, this is really important, and especially when we get to files later, we understand the difference between a formatted text and a non-formatted text. So a formatted text is talking about a string, and we know that because we can read it. So when we put %d here, and we have, let's say, A, and let's say A is 4, what it is literally doing, I'll make the minutes. From memory, we're going to have 4 in memory, okay? So it's taking that and turning it into the character 4 and printing that to the screen. If we put, I should have used my other example. Let's get 65. 65 is that another one. Okay, so we got 65 here. Okay. So we got 65, which is one here. And 0, 0001, and it'll have 4 bytes here with more zeros in Big Indian. So it's going to take what's in there, and this %d will change it to a 6 and a 5, okay, and print it to the screen. Now, if I change this to x, it's going to take what's in here and convert it to the characters for the hexadecimal representation, which would be 000000. And this is something you will definitely have to know how to do, and we'll cover this once we get up to that lecture. So we've got 4-1 there. So it will print the string 00000000. This is really important when it comes to the file. It's actually printing characters. Okay, so it's just converting it to different formats depending on what we put there. Now, if I put %f here, this data storage is incorrect for converting it to a string. And this is why you get a warning or an error. But you usually won't get a warning if you try and do this. And it's the same if you try and use like a larger type or a smaller type. You can always cast it as well if you need. But we'll get to that. All right, so this is important that you understand that it's formatted. It is not function, okay? The F does not stand for function. Okay, so the main format specifiers you do need to know are going to be %d, %x, %c, %f, %s. Okay, can't think that you will need any others. So D is for a decimal integer. X is for a hexadecimal. Now, this is really quite important, the fact that I'm writing integer here. This is an ASCII character. This is a decimal float, floating point number. And this is a string. Okay, so string is array of cars ending in null terminator. Okay, so that's the C definition of a string. All right, be careful, some other languages string has a different definition. Of the C, that is its definition. It is an array of cars ending in the null terminator. So the important thing here is that you've got decimal and it's an integer. So it's a whole decimal number. Hexadecimal, X, will not take a floating point number. It has to be a hexadecimal integer. Okay? This has to be an ASCII character. Okay? And this is a decimal float. Okay, so it's not an octal float, it's not anything else. If you want an octal float or something like that, you'll have to do some calculations. I don't think there is actually a format specifier for anything other than decimal for the floats. Well, not that I've seen. And then you've got the string. Okay, these 5 you should definitely know. Okay. Actually, go to my email and just check something. Actually, I'll ask a question first. No. So, a good question on the exam will there be maths formulas? The hardest maths might be some simple division or subtraction, but definitely not like the assignments. So, the assignments are designed like your
working on a task where the exam's just testing you understand the knowledge. Okay? No, we're not testing your math skills. So you should be able to do basic arithmetic, adding, subtracting, multiplying, and dividing, and that's it. It's not going to be massive numbers either. It's going to be small numbers. Okay, you don't have a calculator, so it's not, yeah, really important. Okay. Now, two other things is we have specifications and flags for our format specifiers. So if I have percent, let's say 6.2F. What does the 6 stand for, and what does the 2 stand for? Okay. So I'll leave that to you. I just want to grab up something to double check. What kind of things? So everyone have a go at answering this. At least if you don't know one, just say don't know, etc. Okay, I'll give you a chance to catch up. Sweet. All right, so we've got a couple of answers there. So most people know this one, which is the precision. So this is the number of decimal places. Okay, the 6 represents the minimum number of characters. So it's not the number of characters, it's the minimum number. And it also specifies that it is right justified. Okay, and I'll show you what I mean by that in a second. So I'm going to add the printf here, and we're going to have a look at a couple of cases. Okay, so I'm going to leave that blank. Now, these two you do need to know for the exam. Okay, don't want an int, I want a float. So float A is, let me give myself some room. So I'm going to say 4. I'm going to say 4. That's a good number. Okay. So I'm going to print this to the screen. Now, the screen looks something like this. The blocks are just every character. So in this case, it's going to print. Now I'm going to make sure I don't fuck this up. Yep. So it will print space, space, 4.00. Okay. So we can see that it prints a minimum of 6 characters. Okay. And it is right justified. Okay, so the number is right justified within that window. Okay. That is really important. Now, if you do add a negative here, it will be left justified. So we get 4.00 space, space. Okay. The plus does not do that. The plus will put a sign always. So if we put a plus here, which is a flag, it will print a plus if it's positive or a minus if it's negative, always. Okay? You'll always get the negative, but you won't get the plus. So the plus will make sure that it has a plus or a minus always. Okay? But the minus is left justified. Okay? Now, if I enter 450, I will get to the screen 450.00. This is longer. Well, this is equal to the minimum, so it's not going to do anything. But if let's go one more. Let's go 1,450. So because it's longer than the minimum, it's just going to print to the screen, and it will print from this point on. Okay, there's nothing to justify it's longer than the space. All right. Now, so you do need to know how to use this. So it's the minimum field length, meaning this has to be 6 characters. Okay, at a minimum. If the number's longer, then it'll just be longer. All right, and we've used this in all the assignments so far. Okay, this number here. Now, this one is quite important as well. If the number is, let's say, 299. Okay, I'll make it 50. Okay. What is it going to print? Tell me what it's going to print in this case. No. Yes. So make sure you remember that this rounds. Okay? Printf rounds. Okay? It does not truncate, it rounds. When typecasting, you truncate, but printf will round. All right? So you need to be aware of that. Okay. Does that all make sense so far? I think that's pretty much all of week 2. That's important. A bit of crap in that, but I don't care about that. There's one last thing. What's /n? Actually, even better question. This one's too easy. Okay. So /n/t, let's say /b. So we've got new line, tab, and backspace. What are these referred to as? Okay. And then I've got /quote, /double quote, /question mark, // What are these referred to as? Okay, because we can't type a single quote or a double quote or a question mark or a line into our code, into our string, because this will end the string and so on. So what are these called? And what are these called? And I'm going to be right back because I've been talking for an hour. So, 2-minute break. They're not the same thing. So one of them's called one thing, the other one's called another thing. You're right about one of them. But which one? So, see who can find it in the lecture notes first. Well, I'll take 2 minutes just to grab a drink. All right, so we all still here, hopefully. So this is called a sequence. And this is called a character. So escape sequence, and escape character. Okay. All right. Let's keep going. There's one other thing I want to show you. So I'm going to have so let's go on to week 3. Okay, so that's week 2 done. I'm going to have int A, I'm going to have int B, I'm going to have float C, I'm going to have float D, I'm going to have yeah, that'll do. So I'm going to do scanf. It prints a question mark. Yes, it does have a special meaning. You don't need to know it though. So scanf, I'm going to read a int, and I'm going to read a float, I'm going to put a space, I'm going to read int, and then I'm going to read another int. No, I'm not going to read a float. Ooh, maybe I'll read a float. And then %d. There's only one space here. So I'm going to go A, C, D, B, and we know that these all need pointers. Okay. Now, if I print to the screen, let's say 12.6 space 2.40. Actually, let's go 2, 4, 8. Okay. What gets stored and where? Go. No, that's a space. So the little underscore just indicates the space because it's hard to see otherwise. Okay, so that's a space. Just because it's hard to see what I'm drawing. It's just me. Yeah, I was going to say, it's a crazy answer.
Does that work? It doesn't. So I'll give you a minute to do that. So once again, if you don't know, say you don't know. Have an educated guess there. Imagine you're on an exam. Okay, I'll wait till there's a couple of goes. All right, so let's go through this. So scanf starts from some point, and it's going to find the first integer. So it scans, it finds the first integer. So A has 12 in it. Then it's going to scan for the first %f. So from this point, we keep going, and we get the first floating point number. So B is 0.6. Then it scans for a space. From here, it gets that space. Yeah, sorry about the keyboard. I should plug the other keyboard in. I can't be bothered though. Then we're here and we scan for the next float. Okay, that's the only whole number, so C is 2. Then we've got %d, so it will scan for the next int. Now it ignores the space, it ignores the white space, that's fine. So we get d is 4. Okay, now when it, does that make sense? I don't think anyone got that right. And I want to know where you got the 0.2 from. So it means that if you try and scan again, it's going to start from here. And as we see in later lectures, when we talk about files, the stream is also a file. And so that's why it will wait here. Okay. Well, yeah, 2.00000. It's not a decimal number, so it doesn't really make a difference if I put the 0.0 there or not. Because in memory, it's going to be stored as a floating point number. But yeah. Okay. So scanf is currently here on the file pointer for standard in. Okay. It will scan for the first integer. So it'll scan this and grab the 12. It then looks for the first floating point number from this point, and it finds the 0.6. It then scans for the first space. That's the first space. Okay. Then it will scan for the first float, which is 2. Then it will scan for the next %d. So when it does that, it ignores white space and reaches here. Sure. Let's just use the same example, but let's change the numbers around. So I'm going to have 18 space, space, new line, space, space, 6.3, space, space, I might flip these around. Okay. I found it destroyed that, but let's go D, F here instead. So I'm going to have B, D. And then I'm going to have a new line, then another space, then another space. Then I'm going to have 18 point 6 space space 18.7. Okay. Have we got that one? Actually, I might change this question a little bit. I'm going to put a comma here instead. Should I? Yeah, put a comma. So I'm going to put a comma there. And I'm going to put a comma here. Should work, I'm pretty sure. Actually, no, I won't confuse you. It's not going to be that hard on the exam. I'll just leave it as it is. So 18, 6.3, beautiful. C, wait, C. A is 18. C is, wait. Yeah, I didn't put them in order. So that might. So remember, it's A, C, B, D. Right. Okay, so let's have a look at this. The percent D will scan for the first int, which it grabs, which is 18. So we get A is 18. And I think I did a mistake before. I should have said this is C and whatever. It doesn't matter. That's my fault. We got C, which will scan for the next float. So we'll keep going, keep going, keep going, keep going, and then it finds it. So that's 6.3. Then we've got B. Yeah, that was my fault. Well, we've got the space, so it finds a space, which is good. And then it'll continue to find the first int. So we get 18. And then we get D, which is 0.6. Okay. Okay, we all happy with that? That's a decimal. Okay. So remember how to do that. It might be handy. No, it is handy. one other thing, I'm not going to go over it right now. We can go over it at a later time. Make sure you know how to do flow diagrams. Okay, they will be on the exam. Okay. And I've mentioned this a couple of times, but we can get to that later. Okay. All right. Yes, the next lab is graded. Remember how we had the break week? So last year they didn't get a break. This year you guys got a break. So you have to do a lab all the way to the end. All right. So another thing is you should know how to use identifiers. I'll cover that right now. Looking for, I thought that was this week. Maybe it's not. Maybe it's the week after. Doesn't matter. We'll do this for week 3. Yes, so your last lab is in week 12. Because we took a break in week 7, last lab is in week 12. There, I have written from last year an exam revision lab, but I might do that as part of the live stream. Do you get steps? That's basically so write a program that implements Windows 10. That's all the steps. All right. So another big one that is usually on exams is something that looks like this. And it's something that you need to be aware of. Oops. Which way let me go? 12, actually. Okay. Okay, what gets printed? I should release the part of it. I'll have a look at the lab. I should be able to release it soon. I just got to change the file name. Update it to 2010. So all the answers so far are wrong. So write your answers. All the answers are still wrong. Okay. So this is something that's always tested generally. It's been on nearly every exam. So we have an int plus an int plus an int divided by an int. Okay. So when the division happens first, because it has precedence, and we have an int divided by an int, what's the largest type? An int. So what's 12 divided by 8? Well, when they're both ints, it's 1. Okay? We lose the 0.5 because these aren't floating point. The result has to be stored inside an int. Okay? Then we add 12 and 8 together, so we get 20. And we have an int plus an int. So 20 plus 1, so we have 21. And then, lastly, it has to be stored in a float, so it gets changed into a float. And so we get 20.0. So we print out 20.0. Or 21, sorry. I don't know why I said 20 when I wrote 21. Okay. There's really good examples of this on your lab help sheet thingy. So how do we get around this if I actually wanted the 20.1.5? What do I need to do? Yes, let's see, no, you don't have to remember the 6 zeros. It's all good. Yes, we have to typecast it. Okay, so we could cast this as a float by writing float A divided by B. Then this will cast that into a float, and so we get, it's not float star times A, it's cast. So it's in front of it. So the only time you'll get into trouble with this, with basic arithmetic, is with division. So when you have an integer type, any integer type divided by any integer type, you get the largest integer type. So you still end up with an integer. You don't end up with a floating point number. As long as one of them's a float, or both of them, you end up with a float. Okay? So basically, whenever you see a division in your exam or in your assignments, go, are they both integers? So just keep that in the back of your head. If you see a division, what do I need to check? Okay. We're happy with typecasting. No, James is incorrect. It's 21. So it doesn't round. So it's 21. Beforehand, before I cast it, obviously. No, it's not float times. So cast should look like this. Even better. So it's the type in brackets and then var. There is no multiplication, there's no nothing. You'll get a compiler error. Otherwise. Okay. So now, where are we at? We should probably have a look at some what's it called? It would be great for this quiz questions. Go to quiz question. So I'm just going to grab some quiz questions because they're kind of good for. Hey, it has that. I didn't know that. Questions. That's what I want. Hard conditional statements. Beautiful. This is what so I'm just going to grab some quiz questions. Before I do that, I'm going to write an if statement. Now, most students get if statements quite quickly, so I'm assuming I don't need to go over that too much. So I've got two if statements here. I'm going to have printf here. It's going to say yes, new line. And this is going to have printf. No. And what I'm going to put here is 4 plus 2. What I'm going to put here is 634. What gets printed? Actually, I might change that. I'm going to make that -4 plus 2. So write what gets printed, and then we'll have a look at a more difficult question. And we'll move on to the next week. It's not much in week 3. It's kind of, there's one big thing we need to cover in week 3 as well. But it's fairly easy. Then I think we get to week 4, which is... Oh no, we're already on week... I don't know what we're on. Oh, we're on week 4. I just skipped over a bunch of stuff. I'm not going to worry about that. I think we're all good with while loops and 2 while loops and 4 loops. Bitwise stuff. Because this will help you with the assignment. Alright, so what will this print? So I've got if -4 plus 2, and printf yes, and then after that I've got if 634, no, you're lying. If you don't know, say don't know, have an educated guess. What would you put on an exam? What's in front of you right now? Okay. So, a really, really important concept is that an if statement will execute. So you can think of it as being true. Anything that is not 0. And false is always 0. So -2 plus 2 results in -2. Is this anything that's not 0 or 0? So it's anything that's not 0. So this will print yes. Then this is not 0, so this will print as well. Okay. Now, it's not that it'll be treated as a 1. It will be treated as it's true. Okay, so it doesn't convert down. This doesn't convert down to a 1. Okay, it's any number in memory, as long as it doesn't overflow. It's fine. You can actually be a little deceptive here if you overflow the number. But we're not going to do that. Because obviously, we don't want to do anything malicious. Or maybe we do. Okay. So I did have a question, but I totally forgot where I put it. Here it is. Okay, so this is a good question, kind of. So have a go at that one. Well, you never know, it might be on the exam. That'd be funny. Maybe it'll follow you around forever. Maybe it'll be on some other subject's exam as well. Just everything. I'll give you a couple of minutes there. Might just, I'll be right back. Okay, have a go at that. If you're still watching, I know there's quite a number of people watching. If you're still watching, please use the chat. I'm I'm only getting a couple of people use it. I know there's more viewers, and I can see who they are on LMS.
Okay, so let's have a look at this. All right. So this is a nice question because it covers a bunch of stuff in one question. So we're going to look at this first. Okay. So we have A is greater or equal to B, and A is 7. Oops. You can see the precedents. These are in the inner brackets, so we do this first. So we've got 7 is greater or equal to B. So that results in a 1. So we end up with 1, not in brackets, sorry. Brackets have been dissolved. So 1 and C is not equal to B, and that's all in brackets. Now, the precedence here is the not equals. So we have C not equal to B. C is not equal to B, so we have a 1. We have a 1 and a 1. Okay, so with an AND, they both have to be true, so we get a 1. So we have a 1 and this not result. Now result is a 1, so not true, this could be any number, is a 0. So we have 1 and 0. So we end up with a 0. So not 10 is 0. Not 463, I don't know why I wrote 2 when I said 3, is a 0. Okay? Not 0 is a 1. Okay? So it's basically, if it's true, it becomes false. If it's false, it becomes true. All right? And as we said, any number other than 0 is true. So this fails, so result is just 1. Okay? However, if this did work and it did turn out as a 1, then we calculate this and we get a 1 still, because A and C are not equal. So either way, even if you got this wrong, you would have got the right answer, which is kind of funny. All right, we're happy with that. So this is not a binary not, it's a conditional not. Okay. A binary not is very different though. Okay. Are we all good? And if you're joining, please use the chat. Please use the chat. Okay, are we good? Are we bad? Are we angry? Are we sad? Still uploading. What's still uploading? Okay. Ah, okay. Does that make sense? I don't know. I think I've gone through a fair bit of stuff. I might try and get up to functions, maybe. So we're up to week 4, and then we'll go on to week 5, and maybe it, unless anyone has questions about the assignment.
All right. So the next thing is the increment and decrement operator. And these are a little confusing. And we haven't used these too much in the labs. And there is two separate types of these as well. So we have the post increment, and we have the pre-increment. We have the post decrement, we have the pre-decrement. Okay, so I'm going to introduce a new problem. I'm going to go int A, int B, and I might actually initialize these. So I'm going to say A is 4, B is 6, and what I'm going to do is I'm going to write int C equals minus minus B. How do I want to do this? Let me just think for a second. Okay, good. Plus A plus plus. Okay. Now this may look a little confusing, but this is perfectly legal to see. Now you may want to bracket these, but sorry, let's introduce something. So I'm going to chunk so sorry, I'm distracted for 2 seconds. So I'm going to do %D, %D, %D. And then I'm going to do A, B, C. So what gets printed? Tell me. Yeah, so have a go at that. So write your answer, what you think it is, and then go on to the next concept. There's spaces, okay. Please use spaces. Okay. So the actual answer is going to be 5, 5, and 11. Okay. So this is why we need to be careful. Okay. And this is really, really quite important. Concept. Okay. So we have this minus minus and a plus plus here. The a plus plus increments by 1, the variable a, but it does it post reading it, so after. Okay. Whereas the pre will increment, then read it. Okay. So we have 4 here, and we'll read that, and it will become 5 after it's calculated, because it's only read of 4. Here we have minus minus b, so it's pre-decremented, so we get 5. So we get 6 minus 1, so we get 5. So b, 5, oh sorry, did I say 11? I just said 9, sorry. That was my fault, sorry. We have 5 plus 4, so we get 9. I went the other way. Then after the calculation, this gets changed to a 5. All right, and so we get 5, 5, 9. Sorry about that, that was my fault. This can get confusing, as you can see. Now you can never do something like this. You can never increment or decrement the same, well, you can, but it's undefined. You can't increment and decrement the same variable in the same expression, okay? It's undefined. So you shouldn't manipulate and read a variable in the same expression, all right? So just be aware of that. All right. Now we have numbers dropping. People watching, which is great. So, who's still here? We lost a whole heap of numbers of people for some reason. Okay, so if the minus minus is before, then it will subtract 1 from b and store that result and use that in the equation. If it's after, so for example here, the plus plus, it will use the original value, so 4, and so we get 5 plus 4, and then after the expression, it will add 1 to a, okay, because it's post increment. So 5 plus 4 is 9, so we get 9 in C, but B has 5 and A has 5. Does that make sense? These are tricky. just because of how they work. So let's make a simpler example. Okay. So I'm just going to go C A++. Okay. So A currently has 4, B currently has 6, and C we'll do in a second. So C here, because this plus is after the A, not before the A, it will take the 4, store it in C, so we get 4 here, then add 1 to A, so we get 5 here. Okay? So the A++ will add 1 to A. However, if the plus is before the A, it will do this increment once, so we get 5 here, and then store that value into C. So depending on the order of this plus is what gets stored. All right. Is that all good? Then we'll do some binary stuff. And because everyone's leaving, I'm going to wrap it up there. I'm just going to go a little longer. But too bad. Are we all up to speed? We all disappeared. All right. So one thing that I can also guarantee you need to know for the exam is your binary to hex and hex to binary. They're the only conversions that you're really expected to know. Okay, you're not going to have to do decimal to hex or something like that. You don't have a calculator, so it's not really fair. Now, what you should do if you have a bit of trouble with the conversion is when you walk into the exam, well, not when you walk in, but after reading time, write down 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1 0 0 1 1 0 0 1 0 1 1 1 0 0 1 1 0 1 1 1 1 0 and 1 1 1 1. Okay. So you can also see if you're struggling with that, there's a pattern 0 1 0 1 0 1 0 1 0 0 1 1 0 0 1 1 0 0 1 1. 4 zeros, 4 ones, 4 zeros, 4 ones, 8 zeros, 8 ones. Decimal has a similar pattern, except for it's not as noticeable because you've got so many digits. But yeah, so you should write this down, and then next to it you should write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So if we have, let's say, the number in hex 4, 5, AB, 3, F, 0, 1. We can quickly convert that by using our table, and we can go 4, that's 0, 1, 0, 0, 5, that's 0, 1, 0, 1, A, that's 1, 0, 1, 0, B, that's 1, 0, 1, 1, 3, 0, 0, 1, 1, F is 1, 1, 1, 1, yeah, that's right, 0, 0, 0, and then 0, 0, 0, 1, and I've converted to binary. Okay, so I can quickly do that. And if I want to go the other way, so let's say I have 0, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1. I missed something, but that's okay. So if I have 1, 1, 1, that's an F. 1, 1, 1, that's an F. If I have 0, 1, 0, 1, then that is going to be 5. If I have 1, 0, 1, that's 9. If I have 0, 0, 0, 1, I have a 1. If I have 1, 0, 0, 0, then that's going to be 8, sorry. And I have another 0 there, so I can always load it up with a couple more zeros. It's the same as decimal. I can just put a 0 in front of the number. Okay, and that's converting. You need to know how to do this. And if you can draw the table out, you can do this in seconds, as you've just seen. All right, we're happy with that conversion. No, you won't get spare paper. You can write it somewhere on the. So you can write it on the back of the paper. So each question should be on its own piece of paper. So you write it on the back of the question paper. But no, you won't get spare paper. You get exactly what you need. You can always ask for a script book if you run out of room for an answer or something. But yeah. All right. So we've got our bit stuff. I'm just going to paste this. It's easier for me, so I have to draw it all out. I don't know why he's going to do some over images, but these tables you should know, and this is quite important, bitwise stuff, and you're doing bitwise in the assignment as well, which is quite helpful. However, you're doing a more standardized way of going about it. So you've got I and j. If I is a 0 and j is a 0, you get a 0. 0, 1, you get a 0. And if they're both 1s, you get a 1. Now, the important thing here is that you're talking about bitwise. And so this is bit for bit ANDed. You've got XOR or OR. And this is wrong. That should be exclusive. This is what happens when you copy from the lecture notes. And then you've got bitwise complement or not. Even though it's not a complete not, when you refer to it, it's usually a not. So if we have 0, 1, 0, 0, 1, 1, 0, 0, and we have that ANDed with 1, 1, 1, 1, 0, 0, 1, 1. You do this bitwise. So 0 and 1 gives a 0. A 0 and a 1 gives a 0. A 1 and a 0 gives a 0. A 1 and a 0 gives a 0, 0, 0, 1, 0. Okay. So you can see that this AND is not a conditional AND, because if it was conditional AND, this would just be a 1. It'd be true. Okay. But here it's going bit by bit by bit. Same here. Exclusive OR is basically if either of them are a 1, but not both of them. Okay, and that's the difference between an exclusive OR and an inclusive OR. So inclusive is either of them are set or they're both set. And this is one that tricks people. So if I have a not here, it basically flips the bits. Now the thing that gets people stuck is, let's say I've got unsigned short, and I'll give this to you to answer. Unsigned short A equals 0B 0 1 0 0 1 1 0 0. And then I go, A becomes bitwise not A. What is the result in binary? We might slowly wrap up, unless there's any specific questions regarding the assignment or otherwise. We'll try and get through some more material once that goes. So you're wrong. Okay. And the reason is, and this is why we have to be careful. So this is a 2-byte number, but I've only specified the first byte. Okay. If I have int a equals 4, it becomes 4. There's still data, but there's lots of zeros at the front. Here, I know that there's 8 zeros at the front of this number. So the negation is going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, because it's a short. Okay? So be careful with that. Does that make sense? Now, yep, all good. Enjoy. I'm going to wrap up soon anyway, so enjoy. Now, in the assignment, we're going to do single bit operations. Always good to do it at the last minute. So we have setting, clearing, and toggling, and testing. Okay. And setting is basically one shifted to the bit we like. And on the assignment, we know we've got macros for this. Clearing is and equals not 1 to the bit we'd like to clear. And this is our status flag in the assignment. We also have toggling. And then we have testing. So testing needs to happen inside an if statement. So we have our whatever variable and 1 shifted to the bit we'd like. Okay. And this bit part is going to be very helpful in the assignment. Is there any questions? Is there anything else you'd like to cover before we wrap up? Because I think that's pretty good now. And everyone's kind of left. We had a good turnout at the start. Any other questions? Any other problems? All right, I might wrap up there. Good luck. If you have any more questions, just email and we'll run the stream again on Saturday. And we might cover a bit more of the assignment at that time and hopefully go over some more revision. All right.